Okay, for our last two pages, there's not really anything to do for examples too much, but let's go over what these graphs really mean. So these are parabolas, and I labeled each of them A, B, C, D, E, F, G to tell you what is each thing. So the A's, A1, A2, A3, those are all real roots. It's where it crosses the x-axis. Now, g of x, we notice that there are no real roots here. There are imaginary roots instead. Also, f of x and h of x both open upward, and g of x will open downward. So that means that our a is going to be negative here, and our f of x and h of x, our a is going to be positive. For b, that is our end behavior. So basically, it's the arrows. Where are they going to and from? So these are both pointing up. So our end behavior is from positive infinity, and then it goes to positive infinity. For g of x, we have negative infinity to negative infinity, and h of x back to positive infinity to positive infinity. So if you ever see a parabola or any kind of equation that has an even, that means that our end behavior is going to be going to the same place before and after. Now, if it's odd, that's when it changes up a little bit. For C, that's our line of symmetry. So we have these dashed lines. So if you fold it down the middle with the dashed line, you'll notice that both of the halves are the same. They will give you a symmetric image. They'll match up with each other. D, that is for directrix. That is this solid line that is underneath our minimum values or above our maximum values. The only thing that I'll say for today is that directrix and focus are equally distant from each other to the vertex. And we'll talk more about that next semester. E, that is your vertex. Again, we have a minimum value at f of x, a maximum value at g of x, and a minimum at h of x. And they get F, focus. We'll talk about that more next semester. It is this point that I put a little bit after each of the vertices. And then G, that is our y-intercept. It's where it crosses the y-axis. And again, here's our y-intercept for this one that I didn't draw in here. Okay, so I, that is our imaginary numbers. Here's one other equation that does show up. It is called Euler's formula. It's e to the I theta equals cosine theta plus I sine of theta. And then for checking for symmetry, for f of x, if f of x equals f of negative x, that's symmetric with the y-axis, which is also known as an even function. If f of negative x equals negative f of x, that's symmetric with the origin, basically the line y equals x, and it's an odd function. And now, if you had the case where f of x equaled negative f of x, that's symmetric with the x-axis, but if you had something like that, it would not pass the vertical line test, and so it would not be a function of x. So that's about it for quadratics right now. If you want to learn more, just search up other YouTube videos. Good luck with your homework and stuff.